Hi everyone, welcome. Thank you very much for coming. My name is Colin Humphreys. As the slide suggests, I work at Pivotal on Cloud Foundry. Now, I'm sure you've seen the name for this talk. You think this sounds like an interesting talk. It's going to be about the lessons that I've learned. This isn't actually the name that I wanted to give this talk. I was banned by the marketing department from using the name that I wanted to give this talk. It was originally called Deployment Pain in One Tool. So I think a lot of conference talks have people talking about the fantastic things that they've done, the amazing things that they've built, and talking proudly and demonstrating the things they've done. So this talk is the opposite of that talk. This talk is 20 years of the incompetent things that I've done really, really badly. So these are my confessions, and I'm going to be sharing them with you today. So this talk is really old man yells at cloud. I'm the old man. I'm going to be yelling about cloud. So the agenda, fairly logical. The past, the present, and the future, that's that. Let's start with the past, which makes sense. Let's go back, way back into time. I started developing on a Commodore 64 when I was 6. Quick show of hands, who's used the Commodore 64? Most people, wow. Amazing. So when I was 6 and I was programming on a Commodore 64, this was the absolute peak of my programming skills. It's all gone downhill since then. There's people here that I work with, they know that's true. They're not laughing, they're crying. I first used Linux in 1998. I used Commodore, which is this distribution. Back in 1998, you could buy the internet on CD-ROM and have it sent to you. Why can't we go back to that? These were simpler times. Commodore became SCO. SCO is a company that now, as I understand, it has a huge amount of patents and pursues those patents. Who said Oracle? Don't say that. They have lawyers everywhere. OK, so I learned a bit about Linux. And my initial experiences with Linux were just to handcraft things. So when I completed my university education, got my first job, moved on in my career, I was building servers by hand. I essentially was either plugging keyboard and mouse into them and monitor, or I was using SSH. So this was going along OK until the first of my big calamities. So I was working at a big advertising agency in London. We had about 1,200 people. I was the systems architect there, so I configured all the servers, did those kind of things. We had a big mail farm, which we called the spam cannon, because you do. We would use the spam cannon for mailing out to customers of other ad agencies to say, hi, we think you're not happy with your current ad agency. And we would email this email out to not just the customer, but to everybody in the industry saying, we think you'd be better with us. We think that the customer's currently unhappy with their ad agency. We do it in a kind of a subtle way, but we basically unseat the customer from another ad agency so that we could get them. So we use the spam cannon for this. You think that's fine. So this cluster of servers had some issues. We essentially lost loads of data. So I rebuilt the thing by hand. Now, the way it worked was we'd line up a job, and then at 3 o'clock in the morning, it would execute that job and do this massive spam of mail out to the entire industry. And then it would delete the job. Now, I was doing this by hand. We took our backups at about 2 o'clock in the morning, which meant we backed up every single job that had ever been done. So when I put it all back again, I restored the backup to the wrong place. I lined up every single job that had ever been done. So what I actually did then, once I'd restored the mail farm, was email the entire industry saying all of our customers were up for grabs. AKA corporate suicide. So that was fairly calamitous. I got into a lot of trouble. We had to put everything back. Not everyone in the agency lost their jobs, but it was very embarrassing for our agency and the entire industry. Moving on, I learned from that. I thought, I won't do things by hand. I'm going to use shell scripts for everything. So moving on in my kind of deployment of big systems. So I scripted the installation of the servers for a big online game of Monopoly. So I set up about, I think it was about 8 servers, a small cluster for this game. It was a massively multiplayer online version of Monopoly. We expected to get about 20,000 people in the first month. So then we got 1.7 million people in the first weekend. So I had to scale it up. And all I had were my crufty shell scripts. And they didn't work very well, and I did lots of things by hand. I did a 54-hour shift in the office without leaving the office to scale this up. During that time period, the game was down. Now, I'm sure you all know that the internet is a very forgiving place. So we have this, Hasbro's Monopoly Play and Meltdown. 1.7 million people failed to access game. 1.7 million people tried to access Monopoly City Streets. You can see there, well, as the kids say these days, fail, all in caps. And this one I prefer because it's just straightforward, to the point, Monopoly City Streets epic fail. So unless you've had articles like this about you, and this was the platform I was in charge of, you probably haven't failed to the same degree that I have. So I thought, I'm going to move on from this. I don't want to use scripts anymore. I'm going to do configuration management. And I use CF Engine. So I did a big Zen-based installation for Volkswagen, big Volkswagen farm, which was Zen-based for virtualization. I used CF Engine to automate this, and I thought this is great. But CF Engine is quite tricky to use. In fact, it's very tricky to use. So I would get the servers running, and it was fine, and everything was happy. And then other people on the team would say to me, how do I change the config on that server? And I said, OK, what you need to do is go and do a master's degree in promise theory, and then come back, read a few more books, and then you might be able to change the config. So the other people in the team wrote shell scripts to go on top of CF Engine, because they didn't want to change anything. So now we've got not just one problem with CF Engine, we've got two problems with shell scripts and CF Engine. So this was pretty bad. So then I moved on to Puppet. Now, this was much better. I built a big farm for all of eBay Europe to run using Puppet. And Puppet had learned from the lessons from CF Engine. It was much easier to use. Unfortunately, the time that I was using Puppet, it had a fairly nasty bug. The same Puppet manifest could converge to two different end states. So we had about 200 servers. We were going to get a big kind of marketing drive with eBay, so we wanted to go up to a few hundred more servers. We scaled them out. The new ones weren't the same as the last ones, even though we used the same config. Now, I know this bug has now been fixed, but it was fairly calamitous at the time. So we had like 50% of requests doing the right thing and 50% of the requests doing the wrong thing, because the way Puppet had traversed its dependency graph differently. So I learned from this, another huge calamity. I'm going to keep going. There's so many of these. This is just, you know this is a 3-hour session, don't you? Just keep on going and going. So then I used Chef. Now, I love Chef. I like writing Ruby. So I love Chef. My laptop is actually built out with Chef. Chef is great for single nodes, but very focused on the individual node. I built out the UK's largest cinema chain, built out their infrastructure using Chef. Chef isn't that opinionated, so it took a long time. There was lots of kind of writing Ruby ourselves. It was interesting to do. Unfortunately, I spent a lot of my focus on, my team's focus on Chef itself. So when we built the setup to be highly available, we had effectively multiple database servers. We built it to be highly available so it could withstand anything. Amazing, awesome. I didn't know about cap theorem at the time, so we built the system such that it essentially went split brain, and for the first, I think, weekend, we sold two tickets to every seat in the cinema, in all the cinemas. So people were turning up with 2 tickets for the same seat, sitting on each other's laps. That wasn't brilliant. That's not really Chef's fault, but I do recommend you learn about cap theorem. It's quite important if you're doing distributed systems. So after that, I'm happily doing my job, doing my Chef installations, and then this thing called Cloud Foundry gets released. So Cloud Foundry, if you haven't heard of it, it's quite good. Now, I had this eureka moment with Cloud Foundry when it was being demoed by the team at VMware. I saw what they were doing. I saw they'd effectively encapsulated my job into a tool, and I thought, I better do this or I've got no job. So not long after that, I delivered the first ever production Cloud Foundry, which was for an insurance company in London. And that went really well. But quick quiz for the audience. Does anybody know how you installed Cloud Foundry in a cluster when it was first released? What tool did you use to do that? Anyone? Chef, bang. Well done, you passed the test. You use these scripts. You can see, I took this screenshot about 2 weeks ago. You can see the last commits are 3 or 4 years ago. You can see they're still in alpha from that. So I installed it via Chef. It was quite problematical. I got each node to do its job, but just about got it running. But it was kind of tricky and kind of a bit hit and miss. So the only instructions I left for the rest of the team in our wiki page was all in caps, do not run Chef. Obviously, I'm in a meeting, the customer wants an update, one of the engineers runs Chef. You can guess what happened. This happened. So, I mean, it wasn't all bad. I mean, I could say the Chef run succeeded some of the time. It's about as nice as a thing as I can say for them. But I loved Cloud Foundry and what it was doing. So I pursued my career at a company called AppFog. Now, AppFog were the first big public Cloud Foundry provider. And I was director of technology there. And it was interesting. Now, can anybody guess what tool we used to deploy Cloud Foundry? Chef. So following on logically, can you guess how that worked out? You guessed correct. So the majority of our effort as a company went into manipulating Chef and trying to get Chef to reliably deploy Cloud Foundry. And that went so well that AppFog had a fire sale to Savis, and half the staff tried to kill the CEO. I'm not sure that's a great criteria for success. So fortunately, I came home before that catastrophe, and I worked on a project for a UK charity called Comic Relief. Comic Relief, some of you may have heard of it. They have to scale up hugely for a donations night once a year. So I thought, this sounds like a job for Cloud Foundry. It's very good at scaling. But about that time, a new thing had come out to help you deploy Cloud Foundry. And that thing was BOSH. So I thought, well, this is a tool made for Cloud Foundry. This has got to be the right way of deploying Cloud Foundry. I'm going to give it a try. So I thought, how hard can it be to use BOSH in 2012 to deploy Cloud Foundry to AWS? It was so painful. My first deploy took 3 weeks. So I thought, I'm going to get this going, or I'll try and kill myself. And then I tried to kill myself, and that didn't work out. And a colleague asked me to rethink and just don't try and kill yourself, give it one more day. And then I got my BOSH deploy working for the first time and had what I'm going to describe as a life-changing moment, which may be overdramatic, but it was. I had this sudden moment when I clearly saw the matrix. I understood what was going on. And I'm going to summarize this moment as this. It's everything else that automates what you were doing before versus BOSH, which means you don't have to do what you were doing before. And this was a huge shift in thinking for me. This is why it took 3 weeks to do my first deploy, because I was still thinking about it like Chef or Puppet. And BOSH is different. I can encapsulate that with this, which I can't read from here, unfortunately. What it is saying is that BOSH Lifecycle Managers large-scale distributed services and not servers. And that is the change. We do not think about servers. We do not care about servers. They are merely an implementation detail. So we at Pivotal have something called the 3 Rs, where we're going to do rotate, repave, repair. We're going to be cycling through servers as fast as possible, destroying them as quickly as possible. So I was a sysadmin. I used to think about, oh, great, I had a Solaris box that had 9-year uptime. We're thinking about the opposite of that. How fast can we be ditching servers so if somebody hacks into them, they have the smallest amount of time to do something with that? How fast can we be keeping everything up to date? Totally different paradigm. Kill the servers. Ignore the servers. Destroy the servers. Think about the services. So I'm going to try and illustrate how BOSH works. I wish someone had done this for me back in 2012. It's going to be very simple, just some boxes and some arrows. So to get BOSH working, you have a release, which is some software. This would be something like Cloud Foundry or Hadoop or Cassandra. Okay? You take that release, you push it into a small VM called a director. This is BOSH itself. So we put the release into the director. Okay? Fairly straightforward. We then take a stem cell, which is just like an operating system, like Ubuntu, something that's trimmed down, just enough. We put that into the director. So this VM now has the software and the operating system. And then we write a manifest, a definition of how we want the world to look, saying that our web servers, we want 5 of them. Our database servers, we want 2 of them. We spell out how we want the world to look based upon these parts of the release going onto this OS. So we write that manifest, we give that to the director. The director now has the software, the operating system, and the definition of the shape of our deployment. We then push that into a cloud, and that is it. Okay? So if you're scared of BOSH, terrified of its complexity, that's what it does. Okay? 3 things, go to an orchestrating VM, and it makes that happen in the cloud. So now we've reached the present. So we're here. As I said, I got my first BOSH deploy going for Comic Relief, and this is how I felt. Thanks to Matt Stein for this picture. I love this picture. But I was a kitten riding around on the back of a unicorn, firing golden bullets. It was awesome. I was so happy. But a logical question, as someone who's worked in operations, is what happened next? What happened on day 2? And this is where I think BOSH actually has its real value. BOSH is the only piece of software I have ever used that is better on day 2 than day 1. Because day 2 is an ops problem now. So why is it better? A few small points. So when you make that declaration, when you write your manifest and you give it to BOSH, you're saying, I want the world to look like this. And BOSH will do its very best to keep the world in that state. So if you say, I want to have my servers looking like this, here's the service, BOSH will keep it running at all costs. If your VMs are misbehaving, it will shoot them and create new ones. It will keep your daemons running. It will keep your service alive and self-healing. If you need to update your software, which you do continuously, it will do that for you. It uses a couple of patterns. So you have something called a canary. So imagine you have 10 servers you want to update. It will try the update on the first one, leaving the other 9 on the original version. If that update fails, it will down tools. So your service carries on running on the original version. If that one succeeds, it will then update the remaining 9 servers in a batch size of your choosing. So if you set this max in-flight number to 3, it will go through and do 3 at a time, leaving you with the capacity to keep your service running, so you have no downtime. So I've written these kind of things before. I've done months of scripting to make this happen. BOSH just does it for you. And scaling, the problem that I had with eBay, where we tried to scale up, double the size of our cluster, the scaling problem that I had with Monopoly City Streets, where I spent 54 hours at a terminal, you don't want to do that. That problem is alleviated by BOSH. As we showed in the diagram, the director has everything it needs to scale up and down. So if you want to go from 2 servers to 400 servers, you change the value in the manifest, you type BOSH deploy, and it does it for you. So my 54 hours of pain, of epic fail, could have been change the number, BOSH deploy, done. So my standard line, which I like very much, I've had 2 really hard problems in my career. The first one is mutable state in a distributed system, and the second one is people. And if you think about it deeply, they are the same problem. So whenever I deal with mutable state in a distributed system, it usually looks like this. You may notice my career looks a lot like this in general, because state is tough. So what BOSH does with state, it encapsulates it in var vcat store. Mutable state goes there, and we mount that in as a persistent disk. This means we isolate it, we treat it with respect. We have a powerful contract there. This means we can back that up. It means if we have problems with the node that's mutating that state, we can shoot the node and mount that state somewhere else. It also leads us towards immutable infrastructure. If that's the only part that's being mutated, it means your file systems can be read-only. BOSH also has a great site behind it, bosh.io. Go and have a look at this. This has many pieces of software, many releases to download. So if you want to get your hands on some software and deploy it, go to bosh.io. Great documentation there as well. So how successful have we been with BOSH? I mentioned Comic Relief. The architecture for Comic Relief looks like this. You can see the 3 top green blobs are Cloud Foundries each. So this has worked fantastically well the last 4 years, built out by BOSH. 2 years ago, we wanted to make a change to all the virtual machines on the day of Comic Relief. We destroyed everything and rebuilt it all from scratch, so from not a single VM to 600 VMs in under an hour with the apps deployed and tested. I challenge you to do that with any other technology. So if it's also good, where's the pain? There has to still be some pain somewhere. This is a talk about pain. We've got to have some pain left, haven't we? So it looks like this. That's our kind of architecture. There is still some pain. So let's talk about the future and how we're going to solve the pain. So the pain, I feel, is in manifests, that declaration. Okay? Because a normal Cloud Foundry manifest is about 6,000 lines of YAML. And the only thing worse than 6,000 lines of YAML is 6,000 lines of XML. Any Spring developers here? Who am I annoying? So this is painful, but we're trying to make them less painful. We're doing that via a few things. The first one is links, so trying to get your kind of like hard-coded IP addresses out of those manifests so you can do service discovery between deployments, those kind of things. Next up, cloud config. At the moment, you define kind of how your IaaS works in every manifest. So we're kind of taking that out so you can do that just once for a BOSH director, and each of your deployments can then reuse it. We're bringing in runtime config. So if you want to have something like a monitoring daemon running on every machine, you can declare that globally, and then every machine for each of your different releases that BOSH deploys will get that. We're also doing bundles. This is where the creator of the release, which is the software you're deploying, they include in their release some templates for the manifests. So when you're deploying that software, you have to write the barest minimum amount of YAML. So you just have to effectively override defaults. You can write far less YAML. And lastly, obviously we at Pivotal have tooling such as Ops Manager and other tooling that we're building, which takes away all the pain from writing the YAML. So you can just use a UI and an API via Ops Manager, and it will write the YAML for you. So this makes your life much, much easier. And then you're happy. So about 50% of my job used to look like this. I had all these things to do around cloud orchestration, operating systems, package management, scaling, writing self-healing systems, updates, all that kind of stuff, storage, networking. This was about half my job. But now I'm old and I'm lazy and I just BOSH deploy. The other 50% of my job looked like this, where I had use an operating system for my applications, bring in the dependencies, do container building, scheduling, logging, load balancing, binding in the services, just so many things, so much pain. And as I just said, I am lazy, I cannot be bothered, I just CF push. Okay? So my job, my career, my 20 years of pain is now 2 commands. And now I can get on with what it was I was trying to do in the first place. So I can focus on delivering value. I can focus on helping organizations learn about their customers and what their customers want, rather than having to wait 3 years for me to craft platforms by hand. So all I'm really asking you in this talk is to please learn from my pain. Learn from the 20 years of terrible, terrible explosions that I've caused. Don't cause your own. BOSH deploy, CF push, and get on with what you're actually trying to do. And that's it. That's all I've got. Thank you very much.